Hi there, welcome to the first episode of Learn to Code C++ edition. I'm going to be going briefly over the basics of what it is to start programming in C++, do a quick hello world and go over some variables, and we'll go from there. So I'm going to be using Visual Studio's 2012 Ultimate for all of the examples I'll be posting. Whenever you open up your program, you want to click on New Project in either in the middle or File, New Project. Make sure you have Win32 console application selected under the Visual C++ Win32. This is going to be the basic starting point for all the programs we're going to be doing. I'm going to name it Learn to Code 01. Alright, so this next window that comes up is a application wizard to try and help you build it. We're going to ignore this. We're just going to hit Next, and then under Additional Options, select Empty Project. This will allow us to have a blank starting state for our program, and it won't put any junk files in there that we don't want to have to worry about. So just go ahead and hit Finish, and then this is what's going to come up. It's going to be blank. So we need to create our first file. So under Source, right-click, go to Add, New Item. Make sure you have CPP file selected. For my main file, I call it main. And I'm going to quickly type out the entry point of our program, and I'll explain it in detail. Main. Alright, so this is pretty small, but you know, big things have small beginnings. So at the top you have #include. This is where you're going to have all your inclusions for files. For right now, we're only going to be doing IO stream. Another thing to note is the greater than and less than signs that surround it. If you do greater than and the less than for looking for files, it's going to be looking at predetermined locations for the C++ library. That comes installed with the packages. If you're doing a specific file to your project, you would use quotes, such as this. You'd do that, and you include your file inside of here. Since we don't have any, we're not going to worry about it. Next thing is using namespace std. This is basically setting our namespace, and I'll go over namespaces later, but for right now, you only have to know that by doing this, you don't have to type out std before you do a command that is a part of IOStream. So let's imagine that I didn't do using namespace std. I'd have to do that for a command, cout. Well, cout is how we print to the console, but we don't want to do std : each time. So since we are setting it to using namespace std, all we have to do is cout, and then hello world. This is our first command that's going to print out hello world to the screen. Make sure you have a semicolon at the end of each line. I'll go ahead and run this. At the top you'll see this little play button in local Windows debugger. Did you notice there how the console popped up and you could kind of see it? That's because the program went into main, it printed out hello world, and then went down to return 0, which is returning control of the system back to the operating system. So we don't want it to hit that, so we're going to do cn.ignore right there, and that's basically going to hold the application open until the user hits enter. So let's run this again, and it says hello world. Great, that's exactly what we want. Beginnings of a program. Alright, so next thing I'm going to show you are variables that are going to pretty much be your tools for building large projects. First one we have is int, which is an integer. Then you have double, which is exactly like an integer, except it can hold floating points. Integers cannot hold floating points. Doubles are also a little bit of a larger number. You have float, which is similar to double, but a little bit different. I'll explain that in a second. Bool, which is Boolean for yes, no. Char, which is a single character, such as A, B, C, not all together, but separately. It can be any alphanumeric value, as long as it's part of the ASCII chart. Then you have char star, which is a character array. That's A, B, C together all in one line. So I'll go ahead and go over some examples of how you utilize these. Let's say for integer, we want to store the number 300. And then for double, we want to store the number 334.23. And then for float, we want to do the same thing for that one, Boolean. We'll initialize this one to true. Character. Whenever you're initializing characters, you need to make sure that you use a single quote, not a double. And then a character array, you use double quotes. Now, some things to note here are the sizes of these variables. And on Windows machines, you have access to the calculator. Make sure that it's in programmer mode. Ints, floats, they're all 4 bytes long, so they are a double word. That's basically going to be 32 bits. Most operating systems run in a 32-bit environment, so you can see all 32 of these zeros, starting from 0 to 31. If I were to fill this up with all ones, except for the last one, that's going to be the sign for if it's negative or not, and I switch it over to decimal, base 10, that's the maximum number that this integer can hold. Now granted, you'd think that you'd be able to hold a little bit more by being able to put one more 1 in there, but watch what happens whenever I do put one more 1 in there. Go over the decimal, -1. So whenever you have a signed variable, the last bit is going to be representation for it being negative. So I'll go into more detail in later tutorials, but essentially that's the footprint on the memory that these variables are having. Doubles are a little bit more complicated. They're 8 bytes long, and they're going to be holding floating points along with integers, and it's this complicated thing that, again, I'll go over later. Okay, so you're probably asking, how do I use this? How do I do things that are useful with this? Well, in programming, you do a lot of algebra and order of operations. So let's say I have an int, call it result, and then I want to do integer times 3. Integer is the variable up here, so it's 300 times 3, which would be 900. Result would be 900. But I want to print this out, so I'm going to do cout result. This takes result, streams it out to the console window. Now notice how it says hello world and then 900. It's all in the same line. Kind of looks ugly. We want to format this a little bit. At the end of hello world, you can put end line, end L. This is the C++ way of creating a new line in the console. You could also put a /n inside of the string stream. This is called a carriage return. Word documents, Notepad, they're filled with these types of characters. They don't normally show up because they're being terminated with that character. So /n will create a new line. So if you're reading this correctly, it'll be new line, which is hitting enter, enter. And there you go. Hello world, enter, enter, 900. I usually like to stick with just end L whenever I'm in a console program, because then I can clearly see whenever I'm creating a new line. Whenever you're writing the files or any type of structure that's outside of the command line, it's best to go ahead and use /n just so you make sure that that encoding is inside the file. So you can do a bunch of different things. You can do another double result 2 equals double times 2.12. Then I'll do inline. So you got 900 and 687.368. Another thing with arithmetic, I'll reuse the same variable as result, so I'll overwrite what's currently in it, is if you do compound statements. So if I were to do 30 times 4 divided by 3. Now, normally you would read this from left to right and you do 30 times 4 divided by 3. However, the computer reads from right to left, so it's going to do 4 divided by 3 and then 30 times whatever that is. Just like with any normal type math, you can use order of operations, PEMDAS, parentheses, exponent, multiply, divide, add, subtract. So I'm going to add some parentheses in here and say that I want to do 30 times 4 first and then divided by 3. And I could do that. So in reality, it looks like that. 30 times 4 divided by 3 plus 4. But since it uses order of operations, we don't have to explicitly declare that parentheses around those. It'll do 4 plus whatever this is last. Another thing to note is if I were to do result 2, which is overriding the double, and I were to do, let's say 2, well, better yet, I'll do result again, and I were to do result 2 times 4. Now, whenever you compile this, it should give you a warning. I'll click on error list, and right here, conversion from double to int, possible loss of data, right here. That's because I'm taking a double and I'm trying to store its result into an integer, and what that warning is basically saying is that, hey, whatever's in that floating position is going to be cut off. So to get rid of that warning for good practice, you just cast it into an int, compile it again, and now that warning isn't there anymore. This other one that's here is saying that I'm initializing from double to float. Floats, I haven't explained this yet. Floats are different in the fact that they are only 4 bytes long, so if you had a large program and you're pressed for space, you'd want to use floats instead of doubles. You still get the floating precision, but it's not as large of a number and it's not as precise. But in order to get rid of this warning, you just put an F in front of the value that you're loading into it, and that casts it into a float. So if I compile it, go to error list, we're all good. Later, whenever I do some more videos, you can just kind of watch how I program to kind of see the style that I use. And programming really is more of a stylized type thing, and as a programmer, you're going to develop your own style, and it's important that you take ownership because this is a craft, and that craft is going to define how you go into do your business whenever you get a job or a career or create your own company. So that's it for this video. Sorry I went a little bit longer than I wanted to. I want to try and keep these to between 10 and 12 minutes, but I'm working on it. So you have a good day and stick around for the next video.